Kia ora, everyone. If you're somewhere that's experiencing the torrential rain, hope you're all safe, warm, and dry. And welcome to our CRISiSLab conversation. CRISiSLab is a technology research hub within the Joint Center of Disaster Research at Mass University. And I'm your host, Alicia Cui, and I'm a science communicator. Today, we're trying a new format to communicate our research. So instead of presentations, I will be asking our invited researchers to walk us through their projects. So it's kind of like interviews, you will see. We will take about 45 minutes and leave some time for questions. And today, we will be talking about using artificial intelligence in disaster research. Before we start, I do want to acknowledge the people who were impacted by the torrential rain the last couple of days. It's very difficult for us to see all those forced evacuations. Some of them are our students, and some of them are friends, and probably people that we know. All those forced evacuation, floating cars, and flooded houses, and slips. So it's also a very timely reminder that our research matter. We will be touching on real-life scenario today as well. Let's get started. So as you can see our screen, we invited 3 of our CRISiSLab researchers to talk about their research. So we have Danuka, we have Alfredo, and we have Melintha. So please briefly introduce yourselves. Danuka.
Yeah, thank you, Alicia. Kia ora, everyone. I'm Danuka. I'm doing a PhD at JCD Mass University. So today I'm gonna talk more on how we can enhance earthquake early warning systems using AI. My PhD is more focused on on-site earthquake early warning systems, and I'm about to finish my PhD. So I think I'm in a good position to be in this discussion today.
Thank you, Danuka. Alfredo?
Hello everyone, I am Alfredo Jaramillo. I am originally from Colombia, environmental engineer and oceanographer in my background. And currently I am a 4-year PhD student from JCDR, researching specifically how to include CTC science initiatives in landslide monitoring programs here in Aotearoa, New Zealand, specifically in coastal cliff areas.
Thank you. Melintha?
Kia ora, everyone. Good afternoon. My name is Malintha. I'm originally from Sri Lanka, from a small beach town in the south called Bentota. So my expertise is in deep learning and computer science and software engineering. So I'm gonna share what I've done so far in my PhD. Thank you.
Thank you all. And as you can see that all our researchers are using AI tools in disaster research. So for example, Danuka's project is Edge AI for better earthquake early warning. Alfredo's project is using machine learning tools to monitor coastal cliff landslides. And Melintha's project is using deep learning for nowcasting. So how high will the flood be at my house, and what will it do? And it's literally what everyone has been experiencing in the last couple of days. So it's going to be super interesting to have the conversation. But before we start on actually what they're doing for their project, I do think that when it comes to artificial intelligence, we hear some of the buzzwords a lot. We hear machine learning, we hear deep learning, we hear large language models like ChatGPT and stuff. But I do wonder how much we actually know, what are the differences. So before we can understand their projects better, I do think it's very important for us to get those concepts out in the way, like what do they actually mean? So I think Melintha will be telling us a little bit about so for example, Melintha, we hear artificial intelligence. I think right now people do have some slight idea of what AI is. But what is it to you? And then what is machine learning and what is deep learning?
Yeah, I know it can be confusing. There are so many buzzwords, and everyone's using them in their day-to-day life nowadays. So I'm gonna briefly, go through all of these buzzwords. So first we'll start off with AI. So AI is basically teaching a computer to do a task that's basically humans can do. For example, like recognizing cat from a dog. So if you show if I show you a photo of a cat or a dog, you're able to tell the difference, right? Because you've seen enough cats and dogs throughout your life to tell the difference. You know the visual features in each of these um, two different animals to identify which is what. So basically, we are teaching a computer by showing enough photos of cats and dogs to identify what a cat is and what a dog is. So we use that concept in different like domains, like earthquake early warning, landslide monitoring, and flood modeling. So that's the idea. So machine learning is a method that we use to teach the computers to do this task. So everything like deep learning comes under machine learning. So machine learning is how you teach the computer. And there are like various methods that you can use, such as deep learning. Deep learning uses this specific method which mimics the human brain. So as humans, we have a neural network in our brain, which identify these visual features of these images and other data, and we use that information processed in our brain to do some action like raising your hand. So deep learning try to replicate this process.
Alicia, you're muted.
Alicia, you're on mic.
Sorry about that. Thank you, Melinda. If I understood correctly, let's say AI is on top, the big umbrella, and then sits underneath is machine learning, and then deep learning sits underneath machine learning. Is that correct?
Exactly. Yeah. It's a
Okay. Then
hierarchy.
Okay, and then I was wondering if people will be wondering about the same thing. So if deep learning is deep learning better or more accurate than machine learning?
Each method is good at some tasks. So for example, for like deep learning is an overkill for some tasks, and it's good for some tasks. Complex,
For example,
for example, if you want to know what's your house's price going to be next year, you can use simpler methods in machine learning to do that. And deep learning is good for complex tasks like recognizing images and then creating essays. So ChatGPT and everything use large language models. Large language models are built using deep learning networks. So it's a pretty complex task to identify. When you give a text to a text message to a large language model, it processes this information and provides you an output as the result, right? So that's a very complex task. So some of these machine learning methods can't be used for that. And deep learning succeeds in that. So it just depends on the complexity of the task.
Okay, thank you very much, Melinda. I think hopefully everyone can understand a little bit better what are the differences of machine learning and deep learning, and why sometimes machine learning is good, but why sometimes we need to use deep learning. Thank you, Melinda. But right now, let's probably start from Danuka, because if you notice that Danuka's title is Edge AI, so maybe Danuka, you can tell us. So besides deep learning and machine learning, and what is Edge AI? Is it also under the umbrella? Is it a sort of AI? But what's the differences?
Thank you, Alicia, and thank you, Malin. for that great explanation. So it simplifies my explanations a lot. So Edge AI, the term has mainly two parts, Edge and AI. So Malintha has explained AI part well. It is like teaching a machine and using some machine to do kind of task that our brain do. So what Edge means, the devices that this AI is running. It can be your mobile phone, your computer, or whatever the devices that are using. So Edge means we are running AI inside the devices that are using in our day-to-day lives. So I'll explain with this an example. So uh, uh, so as an example, you use ChatGPT. Now in ChatGPT, you ask a question from ChatGPT in your web browser. What it does is your question is taken to a server somewhere far, which is a very big machine, and run the AI on that question and get an answer and bring back that answer to your using your internet. Now that is called centralized AI. Now what happens in HAI is, as an example, uh, you can unlock your phone with your Face ID even without internet. So that there also we invoke an AI model, but it is running inside your mobile phone. So that is called HAI.
So whenever we use our face to unlock our phone or using passcode to unlock a phone, that is basically Edge AI function.
Probably passcode may not be invoking AI model, but in to identify your face from the other things, we need to invoke an AI model.
Okay, so face identification is Edge AI, but passcode isn't.
Yes. No.
Why is that?
Because identification of a passcode is very simple, and we don't need an algorithm to do it. It's like just mapping of few numbers. So it does not involve running AI model. But as Malintha explained earlier, like identify your face from other faces is a complex task. Even though our brain did it very fast, uh, when a machine involved, it is a complex task. So we need to train a deep learning model and use it to do that task.
Okay, thank you very much.
Yeah.
Can you please give us maybe one more example of in our day-to-day life, where is this HAI in our life that exists, that we're using it? So does our phone have this
Probably,
HAI?
yes. I think so. Everyone using Siri, right? Apple Siri. So they are probably Siri means like the voice assistant. So
Yeah, the Siri, yes.
I think
For
probably there is
iOS.
an AI. Yes,
Siri
yes.
or
So
Alexa,
I
for
think
example,
there
no?
is an AI model invoked
Okay.
Alexa and any other like transcribing tool. Yeah, they will invoke some AI model to identify what the exact word that we are saying and convert them into a list of tasks.
Okay, thank you, Danuka. And now I hope everyone knows what's Edge AI. And now, please tell us about your research. So, what have you accomplished so far? Maybe you can start by telling us. I think some people know, but for some people who don't know, let's recap. What is earthquake early warning?
So basically, in an earthquake, so earthquake early warning is giving a warning before the exact, the huge ground shaking reach to some particular location. So that is early warning. So we can get a warning before our ground moves. So it can be a few seconds to a couple of minutes. So my focus is more on providing that warning within the its site itself. So before diving into more details, so in an earthquake, how this warning is possible is we get two kind of waveforms. Sorry. So in an earthquake, we get two kind of waveforms, P wave and S wave. So P wave travels faster than S wave, but it is very, it's not destructive. So what in earthquake early warning does is detect this P wave first and then use that P wave information to predict the upcoming ground shaking and give a warning before this S wave comes. So my particular project focused more on a specific kind of early warning system called on-site earthquake early warning system.
Sorry, what was that?
Did I
What?
answer?
I think you're speaking a little bit too soft. So, which specific kind of earthquake early warning you're using?
Okay. So my focus is on on-site earthquake early warning system.
Earthquake early
Basically,
warning.
there are two types of there are regional earthquake early warning systems and on-site earthquake early warning systems. So my focus is more on on-site systems. Yes.
Can you please tell us what's the differences between the two type that you just mentioned, on-site and regional?
Okay. So regional earthquake early warning systems uses many seismic sensors to identify this earthquake and estimate the damage in locations. Sorry, not damage in locations. The highest shaking comes to which part of locations. But on the other hand, on-site systems use a single sensor, seismic sensor, to identify this P wave and deliver a warning.
Okay, so just from one position.
Yes. So on-site means it has the definition of itself. Like on-site means we give the warning to that site itself, not for the whole region of area. The focus is only for one particular site or location that can be a building or a house or something similar.
Okay, so from my knowledge that I know that New Zealand hasn't got an earthquake early warning system yet, but then for the countries or regions who have earthquake early warning system, and are they mostly using the other one than not the one that you are researching on? Can you please tell us about the context of the earthquake early warning system in the world?
Yes, so currently, as to my knowledge, so there are 9 countries which are successfully operating earthquake early warning systems, and that include Taiwan, Japan, United States, Canada, so on. So some countries have on-site earthquake early warning systems as well, like Taiwan and Japan. And there are like 15 countries that the researchers are carried on to implement an earthquake early warning system. And New Zealand is one of in that category. So yes, there are both systems and both have their pros and cons. So I would say like on-site systems are always faster than regional earthquake early warning systems. And then the second most reason is they are very cost effective because they need a very less amount of infrastructure to build such a system.
Okay, thank you. That's very important information. So now we learned that on-site earthquake early warning is more lower cost, and also it's faster. And please tell us what you accomplished in your research.
Okay. So to build these on-site systems even more cost effective, so what I'm working on is turning these sensors. I will explain sensors later. So sensors into an earthquake early warning, on-site earthquake early warning system itself. So what this sensors means is, so we monitor our ground motion or this P wave, as I mentioned earlier, using a seismic sensors. So even in New Zealand, we have thousands of these sensors. These sensors can be some sensors are high cost and some sensors are low cost. So my focus is to turn these low cost seismic sensor into an earthquake early warning system instead. So to accomplish this, we have contributed three main things. So first is to detect this P wave fast enough, and then using that P wave that we have already detected, we need to estimate what kind of shaking that will be on the same location, kind of ground movement. And also we have developed another model that can estimate the magnitude of this earthquake within just 2 seconds of P wave information. So to accomplish these two tasks, we have built two deep learning models. And finally, as our third contribution, we have compact these two models into a very low resource seismometer called Raspberry Shake. So that is our third contribution. And to my knowledge, that is the first place that we can see such a kind of complex deep learning algorithms are running inside a very small device like Raspberry Shake, which is very low cost and capable of providing warning right now.
For people who don't know much about sensors, what is Raspberry Shake? Because when you talk about Raspberry, people are thinking about a completely different thing.
Yes, yeah. So Raspberry Shake is a sensor that monitors the movement of the Earth where it is placed. So what that sensor do is they monitor the movement in the form of acceleration. So these sensors are typically measuring the acceleration in its surface and sending the data to some particular server. So instead of that, that is what most of the seismometers do. They are measuring the acceleration of the surface at which they are placed.
Acceleration? You mean the
Yes.
ground movement? Yeah.
Ground movement, yes.
Yeah.
So what we do that was instead of sending data away, we process data inside those sensors and providing capable of making these sensors capable enough of providing warning by themselves.
Okay, so from my understanding, so this Raspberry Shake sensor, which is rather low cost, and then it can detect earthquakes, and then using perhaps your algorithm, and it can send out alerts. So it can detect and send out alerts just from one sensor. Is that correct?
Yes, that's exactly correct. Yeah.
Okay, and then tell us about maybe how fast that your particular Raspberry sensor can provide in your research.
So that's a good question actually. So once the P wave is arrived at a particular sensor with our algorithms, so we can detect this and P wave and provide a warning within just 2 seconds. It's a complete warning. That means upcoming ground shaking intensity and the earthquake of the magnitude of the earthquake as well. So it will take just 2 seconds to deliver this warning.
2 seconds sounds really, really short, but before we wrap up, because that sounds pretty cool, I think it's good to give people a perspective. So versus how many seconds in other situation?
What do you mean by other situations?
Oh,
The
sorry.
existing systems?
Let me put things in a more clearer way. I mean, you just told us that from your Raspberry Shake sensor that using HAI, it takes only 2 seconds to detect and send out a warning. So for what you know about other earthquake early warning in the world, usually how long does it take for them to detect and send out a warning?
Yes, that's a good question, Alicia. So I know about P alert. That is also one of the on-site earthquake early warning systems, which is heavily used in Taiwan, I think. So they take 3 seconds of this P wave and run some physics-based equation to decide what is coming in front of us. So in our research, in our second contribution, so what we did was we have benchmarked, that means we have compared our result with that P alert method, and we show that our method is very accurate and faster than the same method.
Okay.
Did I answer that question?
Yeah, I think that's enough for us to hear that Taiwan needs 3 seconds and you took 2 seconds. That sounds faster indeed. Thank you very much, Danuka.
Okay.
And I think we need to move on to other researchers to talk about their research. But thank you very much. And if anyone has any questions, and feel free to ask later or drop in our chat box. Yeah, thank you. Alfredo.
Yeah.
So you're going to talk about like citizen science and using machine learning to monitor coastal cliff landslides. Tell us about what is citizen science to start with, please.
Good question, Alicia. Citizen science means that common people or everyday people contribute data. Often they using their phones, for example, and we use the AI tools to help us to make sense of that kind of data.
Okay.
So yes, and Alicia,
so
for
everyone
example,
can be a citizen scientist.
Yes, everyone can be a citizen scientist. There are a lot of projects on the world that the people is engaged to participate. Sometimes, or more of the times, is participating with data, contributing data with the phone, for example, taking photos for animals, for the beach, for the sky, to recognize some patterns in the project, but they are contributing data. So
Thank you.
in Landslides research, Alicia.
Sorry, can I please ask
sure.
one question before you talk about landslides? So
Sure.
there are researchers, there are scientists. So why do we still need citizen scientists?
That is the key part of the citizen science in the research project. There are two main reasons. One is the time gap that we find in most of the data sets, in the data that the scientists are collecting from any project. So we have limited resources like scientists to be in the field every day or in all the sites that we are studying. But we have a lot of eyes, a lot of people in the sites that can take photos for us, can take some measurements for us, can report some observations, and we can work remotely from that sites with that kind of data. So that is one of the important reasons that the citizen science is used in the scientific project. The other is there are a huge gap between the community and the science. The people don't believe, or some people don't believe totally in the science, for example, in the data. And the scientists, sometimes we cannot communicate properly with the people. So the citizen science is a very interesting initiative to close that gap and make more close the relationship between the people, the community, and the scientists.
Thank you very much, Alfredo. So tell us about how, someone claps. That's good. So please tell us, how did this citizen science help you with your research? And also because we have a AI, artificial intelligence kind of thing. And then maybe later on I will ask you to tell us how are you using machine learning to help you as well.
Yes, as I was mentioning, Alicia, in Landslides research, we simply don't have enough scientists in the field. but we have thousands of people taking photos every day. Cities designs allow us to use that photos as available observations, then help us to process large number of images quickly using the AI, no? Identifying changes in slopes or detecting some cracks in the cliff, or even mapping landslide that is very important for the inventory of landslides in an area. For example, after Cyclone Gabriel, we map thousands of landslides manually, but that data is used in Earth Science of New Zealand, is used for train AI models to improve the recognition of that kind of patterns in the satellite imagery. So, for instance, Alicia, another good example is the platform that I am testing in my project that is called CRISiSLab. Is a station that we install in some specific sites to ask to the people to locate the phone and take a photo in the exactly same coordinates, same position and same angle. And the people can send the photos every day or every week when they can, when they want. That allow the people to take the photos and allow us to work with that kind of material, that kind of data, and combine it with AI. Those images can become a powerful monitoring tool. Actually, CRISiSLab was created to monitor the coastal erosion in different sandy beaches.
Where are those locations? Do you want to share with us? Maybe some of the people who will go there and they can perhaps participate in your CRISiSLab citizen science.
Thank you, Alicia. Yes. Can I share my screen and show, for example, what kind of photos we are collecting and
Yeah,
explain
sure. Yeah, please
Give
share
me
your
1
screen.
minute, please.
Yeah. And also, Danuka, I think some people asked some questions in the chat, and feel free if you think you're able to answer those questions in the chat, feel free to do so. But otherwise, we are happy to recap all those questions later on together. Yes, Alfredo?
Okay, this is one of the examples of the photos that we are collecting. This site is in Onero, in Taranaki North, here in New Zealand. And we have a citizens taking the photo from the same position in the fence of his house. And we can see that, for example, in 11 days, all of these debris that occur in a rockfall in this cliff disappear for event of the tide of the waves in this area. So using this tool and using the machine learning tools that I will explain later, we can identify some features like the debris, like the blocks, like the cracks, the vegetation that could be a good indicator that something is happening there. We have another location that is Cape Kidnappers in Hawke's Bay. This is that example. Maybe this cliff is more stable than the previous one, but we can see some changes in some parts of the cliff. And there are another, maybe it's not here. This one is Urenui in Taranaki as well. But there are another, I don't have photos to show yet, but it's in Auckland, in Mairangi Bay. That three sites in my research project, Alicia, have an important meaning, at least for me. That is, we have different geology that conform that kind of cliffs, and we have different type of persona of people participating in this kind of initiatives. So, for example, in Cape Kidnapper, we have more tourists going there and coming back. In Auckland, we have more residents concerned about the coastal erosion and the price of the houses there. And in Taranaki, We have the EWI community that is very engaged with the project, taking photos for us with Nyati Mutunga. That is very keen, very keen to help us. So yes,
Yeah.
that is the three
Yeah.
sites that we are including in the project, Alicia.
Thank you very much, Alfredo. I do have a question before we wrap up and moving on to Melintha.
Of course.
So for all those kind of changes that you showed us and or reflected from all those photos, how did this machine learning tool identify whether some changes are just normal changes because of the weather or some changes are alarming for potential landslides? Did I make myself clear?
Yes, Alicia, it's interesting. At this stage of the project, we are testing if this kind of data that the people is taking for us is contributing in the project could be useful to identify these kind of things, the cracks, the fractures, the blocks on the beach, no, the debris. If we can use this kind of data, and if we can recognize with the machine learning tools, maybe we can, in a future project, maybe create an early warning system that we can, depends of the frequency of the data that we are collecting in each site, we can see, okay, this crack is increasing the size, and we can send a early warning or a warning to the council, for example, to close the beach. But I am thinking in a specific case that could be Cape Kidnappers, that in 2019 occurred a very big landslide that injured two tourists that was walking at the same time. They was in the wrong place and in the wrong time. But if we can maybe identify that kind of features that is like a proxy that can indicate that possible landslide will occur in a couple of days or weeks or after a storm or an earthquake, we can say to the council, take care, regulate the enter to the site, because it's a very straight area. It's 4 kilometers of beach that the people have to walk only in low tide and come back. No, that is one of the possible uses that we are looking for in the future with this kind of project.
Thank you, Alfredo. So how when shall we know about this? Because I know that you're still in the progress of your research. Yeah. And how long?
I am in the final year, Alicia. I am in the 4th year now, so I am just trying to finish this journey in the PhD. But as always, if you ask to all of us, we start with 1, 2, or 3 research questions, but at the end we will finish with 10, 12, 20 questions more. No, so we will. This is a very good opportunity to think in the future projects. That is the idea. I am using the AI like a introductory or a starting stage for the use of AI to identify these kind of features. But if it's useful, we can start in a future project to train a proper machine learning tool to improve this technique and to apply in another kind of environments. I am testing this in coastal cliff areas because based in my background, I have more experience working with coastal erosion. But that doesn't mean that this cannot be applied in a common landslide or in another kind of mass movements in other kind of environments.
Cool. Thank you very much, Alfredo, and good
You're
luck with
welcome,
your
Alicia.
project. And we're looking
Thank you so
forward to
much.
see whether citizen science and using machine learning tools will contribute to identify the potential landslides. Thank you.
Thank you.
Okay, Melintha, So yeah, I think people probably think your project is very timely, and it's about flood, and a lot of people were impacted. So tell us about what your project can contribute. Maybe for the start, what is nowcasting? Because we hear about forecast a lot. And what is nowcasting? What's the differences and why it is also very important?
That's an important question. So you've heard of weather forecasts. For example, if you go to a Met service, you can see the forecast for next few days, next few hours. So nowcasting is a specific type of forecast which uses current conditions like information from sensors or information from other, like observatory equipment to forecast the immediate future, maybe a few hours ahead, or a few minutes or a few hours ahead. It's a really short-term forecast. And it's simply put, it's forecasting is tomorrow, nowcasting is few hours ahead.
Would it be a little bit too late? So and maybe you can tell us under what kind of circumstances that maybe there isn't enough capacity to forecast. So nowcast becomes essential.
We can take the recent event in Wellington as an example, I think. This is a local weather event, I guess local weather system developed over a very short period of time and then gave us an unexpected amount of rain, causing floods in places where we never imagined that would flood, right? So it kind of overwhelmed the drainage system in our suburbs. For example, if you've been to Island Bay, Island Bay is a place that I had never imagined would flood. I used to live in Island Bay. Some of the streets I saw the photos. I couldn't believe my eyes. So happened over the night. So that's a very short the event developed in a short amount of time. That's where nowcasting is important. Forecasting is for a long, essentially for like a medium or long range. Nowcasting is for very short range, from few minutes to hours.
Okay, thank you very much. So how did you use deep learning to help with this nowcast for the floods?
Okay.
Are we talking about flash floods? Do you want to also tell us what is flash flood?
Yes, so I'll quickly go over different flood types. So there are dozen of flood types. Flash floods, river floods, coastal floods, surface flooding, fluvial flooding, urban flooding. So a lot of terms.
There's lots of terminologies here. Maybe pick a
So
few
what
of
happened
very
in
common
Wellington is
ones.
a flash flood, flash plus urban flood. My research looks at
Is Melintha's screen frozen? Okay. Let's just wait for him to come back. But meanwhile, I already saw like yeah, we have quite a lot of questions in the box. So thank you very much for the enthusiasm. While we're waiting for Melintha, does anyone have questions for Alfredo or Danuka? Or if you pick up the questions in the chat box, feel free to answer. Yeah, I think we lost Melintha, but I'm sure he will try to come back.
Yes, no problem, Alicia. I can ask to everybody, as I mentioned in the chat, that actually CRISiSLab was an initiative developed to monitor the shoreline retrenchment the coastal erosion in the beach, in the sandy beach. We are trying to use in another kind of environment. But yes, the answer is that we can install in Eastbourne, for example, or here in Wellington, in different beaches that have the important concern about the coastal erosion, we can install some CRISiSLab stations and try to monitor and collect more data for the council and take the decisions based in data.
Okay, thank you, Alfredo. And Muhammad has his hand up. Feel free to unmute yourself and ask question.
Hi, I'm Mohammed from Pakistan, and thank you all for your presentations. And I just want to ask that all matlab means early career researchers and bachelor student like me are listening to you and understanding your research. What would you recommend them to work on in the future?
What's your background, Muhammad? That's a very broad question.
Yes. I'm currently in my final year of my bachelor's in civil engineering, and I have also published about 10 to 11 papers in my bachelor's, and I'm currently working on earthquakes, and so that's my question right now.
Sorry, Muhammad, thank you for your question. And I think Melintha managed to rejoin us. So do you mind that hold your question first? And also, we will be sharing our researchers' information. I think if it's about future topics, then maybe we can leave time for after this conversation over, and you can reach out to for our researchers to answer your question. Welcome back, Melintha.
Oh, sorry, about the
That's all right.
interruption.
Yeah,
Wi-Fi.
that's all right. Yeah, you
I've
were
been
just
having
telling
Wi-Fi.
us about urban flood.
Yeah, so what was your question again? Sorry.
No, you were telling us about a few key, very common floods and the differences. And yeah.
Yeah, so flash floods are very short-term events, like happens really quickly, fast-paced, whereas like river floods spans for a couple of days, hours or a couple of days. Flash floods, I guess we just experienced a flash flood in Wellington, flash plus urban flood. So that's the difference between like there are other types with how what's the driving factor of the flood and where is it happening. It the flood can be a combination of different types of floods as well. If it's a beach, a town close to the beach, there can be coastal flooding as well as most of these towns in a beach area has a river going by as well. So it can be a river plus a coastal flood as well. So there can be a combined effect as well. And when it happens over a short amount of time, we call it a flash flood.
Yeah,
so
so
I
it's
know.
difficult.
Yeah.
So it's difficult to forecast flash floods like
Yes.
many people experience the last couple of days. Yeah.
Yes, so that's why we need nowcasting methods. I will touch on how I use AI, like what's the purpose of using AI in this case. So the idea of my project is to kind of to make forecast or nowcast localized so that we know what will happen during the flood and we can make effective decisions if we know that information. For example, if we know the amount of water that we will get in our household, we can make a decision based on that. So to do that, it's very hard because flood modeling involves a very complex process called hydrodynamic modeling, which takes time, hours if not days, which we don't have in a flood event. We don't have the luxury of time in a flood event. So if you have used AI like ChatGPT or any large language model, if you as you provide a message, you get the response instantly, right? They are really fast during inference time. Takes a lot of time and computational resources to train them, but during when we use them at inference, they are really fast and cheap to run. So if we can kind of use AI in this case, we can get some good enough information to make decisions based on. So that's the idea.
So thank you. So how do we make sure, or how can we trust it though? If we use AI, say, if I understood correctly, I took a photo. So for example, I already discovered water coming into my house. I took a photo, and then your model will tell me how much time do I have until the water come up to how many meters? How do we understand how helpful it will be, or what is it really like? Picture as a scenario if you can.
It would be like there will be so everyone uses mobile apps these days. So your mobile is your closest friend, I guess. So you could enter your address in your mobile app and see how the risk at your location evolves over time. Like over the time, how what's the flood level, water level expected during next few hours, and I guess you could make decisions based on that. To your question, to answer your question, so ideally you would be able to like tell the app or the mobile app that what's the current condition is, what's the level of water at the moment, but that needs research still. But I'm trying to simply do this, try out this, and then to see if it's possible at this level of detail. So that's the idea.
Thank you, Melintha. And I'm thinking, because I'm watching the time, I do see two people raising their hands, and maybe I've asked enough questions, and maybe Debbie, if your question is about Melintha's topic, go ahead.
Can you all hear me?
Yes.
Excuse me, kia ora koutou. I live on the top of the south in Marlborough, and thank you so much to all four of you. This is really fascinating and I think very encouraging, particularly under the current circumstances, to hear how many advantages there are with AI and what's being looked at. I think some of the questions I have at the moment are around the cons of AI. So the three that come up at the moment relate to urban bias, because most people who are designing AI algorithms, etc., are living in an urban environment and not in a rural environment. The second is around privacy, and I think you talked about having an app, and of course we all do, but if data is the new oil, who's got that? Where's that data going? And information about ourselves, particularly if it's at our home. And then the third is around energy and water, because I'm not a tech software person. My background is around One Health, so where environmental and public health meet. But my understanding is that data centers and AI require huge amounts of energy and water, and are those then contributing to the human-induced climate change issues that we're using them to solve the problem with and shooting ourselves in the foot? I know those are really deep and big questions, and we have about 2 minutes left, but I am curious to know what discussions are around and how those factors and sort of the negative sides or the cons are being thought of when aspects are being designed.
Thank you, Debbie. Good questions. Who wants to answer one by one, maybe? Alfredo?
Okay, maybe I can start for the question related to the consuming of energy and environmental issues. I am an environmental engineer, and also that is one of my common concerns about this. And reflecting about this, I think that is a topic that we need to discuss in more spaces like this one. We need to communicate properly to the people how to use the AI, because as I say, we don't use a canyon to kill a fly. No, we will not use AI to solve short problems or easy problems. We need to use properly this kind of tools, conscious about the energy consuming that they include. So yes, I think if we use correctly, the consuming of energy will be justified. And I think we are working at the same time to move to another energy sources that could be included in this kind of tools in the data servers and in all the process that include.
Thank you, Alfredo. Just watching the time before, because I think if people can continue, and let's continue. But if people needed to leave, I just thank you for coming. And it's a kind of testing the new format. And I realized the 1 hour is not enough for a deep, great conversation. Next time, maybe we'll extend more. But let's continue to ask those questions, answer those questions. Malintha, Danuka, either of you want to contribute?
Yeah, I'll and thank you, Alfredo. Like that, that's a very good explanation. I'll add a different perspective on this energy consumption of the AI. So, and the concern is very real. Uh, so I will add two perspectives. First one for the developer side. So at CRISiSLab, what we are trying to do is like bring AI to the edge. So that involves like reducing the consumption of the power of these models as well. So we can have a very big model and very small model. And if we design this small model precisely, then we can get the same level of accuracy with even with a very small model. That means low consumption of the model energy. So that's one aspect for the developers to try to more focus on compressing these models into smaller ones with same performance. So the other aspect is from user point of view. Uh, so especially with this in the current decade, so we are heavily depend on relying on these generative AI models like ChatGPT. So uh, I remember at a time the CEO of OpenAI, which is ChatGPT, where ChatGPT the software came from, said like we don't need to we should more focus on what we need to get out of these models. Don't say like the words, please give me the answer, because please itself is consuming some energy in a server somewhere far. So they are just tools, and be conscious when you are using as from the user's perspectives to reduce the energy consumption in a place where we even don't see. Yeah.
Yeah, thank you, Danuka. I think that's worth probably another separate session, because I use please and thank you all the time. I just feel like I want to. But yeah, that's a good point. Thank you. Malintha, and because Debbie asked quite a few questions, and we have other questions too. So let's keep it simple, keep it concise.
Yeah, so I'll answer the biased part of the question.
The urban one, yeah.
Yeah, having biases is a problem for AI models. The way to address that is like improve the quality of data that's used to train this model, because these models learn from data. So as developers, AI model developers, we need to address the quality. So if we are like training a model for flat modeling, we need to kind of gather all the data, like representing all the cases without, like being biased on a specific location or specific type of features. So that's one way to address that, and then design choices as well. And there's an emerging field called explainable AI to know how AI model made it decision or prediction based on a given input. So it explains why it came up with that output. If you have used ChatGPT, it explains you how it arrived at its output, right? So you may have seen that it gives you a set of like steps that it followed to come up with that particular response. So that's going to be I guess, a part of process in reducing biases and uncertainty of these models.
Thank you. Hope that answered most of your question, Debbie. And maybe one more. I saw, oh yeah, Muhammad and also CRISiSLab. Muhammad, what's your question?
I would like to ask Malintha a question that we
Yes.
have in Pakistan. We have in Pakistan an app named Park NDMA Disaster. When we install this app on our phone and we enter our location, and when we on the any hazard alert or means storm alert or anything matlab means earthquake alert, when the hazard is going to happen, it will notify us, and it will give us time that in how much time this storm, yeah, this hazard will reach us, so that we can relocate ourselves and something like that. Melintha, I think you are talking about computer vision or something like that, or maybe I am unable to understand your research completely.
Yeah, it's so I'm proposing something like that, I guess. But there are like a set of challenges to achieve that. One is the modeling complexity here. So we are talking about floods, which is a complex physical process. To provide good enough information, we need to do good enough modeling. So the current modeling process that we have has a separate field in civil engineering called hydrology and hydraulics, which these simulations takes hours, if not days. So we need to overcome that challenge first in order to achieve this app that we are talking about. Yeah, but we need to deal with we need to deal with uncertainty as well, because we are talking about life or death situations here. Like sometimes when we provide information, they should be accurate enough, or the uncertainty should be communicated so that people can understand it. Otherwise, misleading information could lead to very disastrous situations. So.
Thank you, Melintha. Muhammad, are you a PhD student studying in New Zealand right now?
No, I am in Pakistan.
Oh, okay. Oh, thank you for joining from Pakistan. Keep in touch. We will be sharing researchers' information. So I think you probably want to have a further discussion with some of us. So feel free. Thank you for your question.
I'm planning. Yes, I am planning to move to New Zealand for my master's. We'll talk about that later.
Cool. Thank you, and good luck with that. And then the last question, CRISiSLab.
Hi. Thank you for hosting this webinar. I mean, this is great. My question to Dhanuka is, I mean, you are working on-site early warning. I mean, we are also
can
working in India.
Can you please slow down a little bit? I think you're speaking very quickly.
All right. So, Dhanuka, I mean, we have been working here with IIT Roorkee, and we have already, developed regional earthquake early warning. And these days, I'm working on-site early warning system. And even I have got a pilot with a Dubai-based infrastructure company. So my question to you is that you said you're only using one sensor. So how do you remove the problem of false alarms? Like any signature of noise can mimic pH. So how you are doing it?
Actually, that's a very good question, and there is
Can you
a
please,
prominent
Dhanuka,
challenge.
quickly repeat? Because I think maybe some of us didn't actually catch it.
Okay.
Repeat the
So
question.
the
Yeah.
question was when dealing with on-site systems, we need to be very careful of the false alerts because since it is a single sensor, we might get a lot of false alerts because P waves are a particular kind of vibration, and if we don't classify this vibration from other vibrations, that will essentially cause of false alert. So to answer that question, so what we have done is actually we have done few things to address this. The first thing is that's why we shift from conventional physics-based model to deep learning model even for the front-end detection. That means detecting these P waves in real time. So when training these models, what we have done is adding enough complex noise in the noise dataset and challenge them to classify in the training. So in that time, we had to add actual noise and we have to increase the complexity of the noise, like adding some more synthetic noise and then simulate some kind of footstep noises into the noise dataset. So because there are some kind of there is a pattern of P wave. There's a pattern means there's a shape of P wave which can be different from other signals, and machine learning or deep learning is very good at identify these shapes and patterns. So that's why we use multiple deep learning models to first detect the P wave, and then our second model is also doing extra layer of verification, which is on top of the first detection. And this way, we could hugely reduce this false alerts. So I will explain to this one. So we have tested our models with query blast events. So query blast is a place where we
Is Danuka's screen also frozen? Okay. Okay, that's right. I think we're a little bit over time, so thank you all for staying to this late.